Okay, so back to the research question that we were interested in, and it was comparing statin users against non-users. So we started off with 130,000 users and 600,000 non-users. So we calculated a propensity score amongst that patient population using logistic regression and this list of 30 variables. We then looked forward to see who got a record of pneumonia. And it turned out 1,400 of the statin users and about 7,500 of the non-users did. So here's the distribution of propensity scores amongst that population. So it isn't nice like in the Till-Sturmer cartoon example. What we've got is, amongst the non-users, a big group with a very low score. That intuitively makes sense. And it may not be so visible to you, but we do have a few people with very high scores, but very, very few of them. Okay. Amongst the users, we were a bit surprised to see that not so much this peak towards 1, we'd expect that. These are people who you'd think should be taking statins. But there are quite a lot of people who are at the lower end of the score. Any thoughts on why we might have people, quite a lot of people at the low end of the score? I can think of two quite different reasons why we might have people at this end. Well, one is, remember we're using electronic health records to do this, and they're not perfect. They exist for a clinician to keep a track of their patients, not for me to do research. So it's possible that I'm missing some important information on the patients. So it could be these people have got really great reasons for being on statins, but it's just not in the record that I've got access to. So it could be some missing data. And this is a big problem for me if that's the case. I can't verify if it's the case, but it could be. It's also possible that there are lots of people who are taking statins who we might call the worried well. So these are people who are not ill, they don't have big risk factors for heart disease, but they feel that they just want to prevent any future harmful outcomes. And so they've asked their doctor for a statin because they're worried that they may get a heart attack. Okay. I don't know whether we're in that situation or the situation of missing data. It's impossible for me to tell. There could be other options too that I've not thought of.
So just another random question. So it will be possible if I don't have any risk factors, I'm just worried about them, and my doctor will still prescribe regardless?
Potentially, yeah. Yeah. So it could be, so remember that these are not people with zero chance of being prescribed a statin, just low. So it could be that you're in an age group where maybe you're my age and you're worried about heart disease. Maybe somebody distant relative of mine has had a heart attack, and so I've just thought, well, I want to prevent that if I can, so I'm going to take a statin. And so in the UK, potentially you would have a discussion with the GP, and if you insisted, maybe they would put you on a statin. Yeah. So remember I said that there are different ways of using the propensity score, and one is to match individuals with similar scores. Well, the problem is, because we've got very few people with high scores amongst the non-user population, if I match people, I'm going to run out of potential matches for all these people here with high scores. So I maybe will lose some important information by doing this. So we decided not to match, and instead we decided that we would adjust for the score in the analysis instead. Okay? So that means we have a statistical model where we just have the exposure, statin or not, and the propensity score. And this could be as a categorical variable or a continuous variable, depending on what made most statistical sense. But who did we include in the analysis? So here's a really busy table, and it shows you the breakdown of the data into 20 groups of the propensity score. So 1 is the people with the lowest score, 20 is the people with the highest scores. So this is our sickest group and our healthiest group according to the data we've got. And here you've got the unexposed group, and here you've got the number in each category and the number of people who died in each category. And then the same for the exposed group. Okay. Now, what you'd notice is that we've got, first of all, we might want to think about the extreme ends of the score. Remember I said that I'm worried that people at the very extreme ends who are treated contrary to their score are weird. There's something odd about them. So we decided up front, this is before seeing the data by the way, we decided up front that we would definitely not include the people in these number 1 and number 20 groups. So we left them out of the analysis. Interestingly, what we also see here is that in the unexposed group, if you look down this column of deaths, you've got all the way down in the mid-teens, mid to high teens, the percentage of people who die in each of these groups. So it's about 15 in this, 14, 17. Amongst the sickest group, number 20, in the untreated population, we only had 8% of them die. So that, in a way, the people who seem to be the least likely to die are our sickest group who are not taking statins. Now, this would make me worry that I'm somehow missing important information on that group, potentially including whether they died or not. Because I can't think of any good biological reason why my lowest risk of death would be in this group. Seems odd. So anyway, we decided to leave that group out. We then, having looked at the data, decided to leave out this group here. The reason being that there are very, very few exposed people and there are almost no outcomes amongst the exposed. So this is, if you like, is our group where almost everybody is untreated. So this doesn't seem to be a very useful comparison. It meant that our primary analysis population was then just the group in the propensity score groups from 9 to 19. So if you imagine you were doing a regular cohort study and a multivariable analysis, this is quite different to what you would have as your primary analysis population in the final analysis. So here are the results. So what we found was that for the category, so groups 9 to 19, our hazard ratio for death following pneumonia was 0.67 and confidence intervals were 0.49 to 0.91. Now, you might just think, well, you've just run an analysis on quite a small group or a relatively small group of your whole study population. Maybe you just got the answer you wanted by doing this cherry picking which group to analyse. So we've also looked at what would happen if we included a different population in the analysis. And so first of all, let's look at what would happen if we included everybody from groups 2 through to 19. Well, in fact, it makes almost no difference. So it turns out our hazard ratio will be 0.66. So it's very similar. And what about if we included absolutely everybody? So this would be more similar to what would happen if we did a traditional multivariable analysis. And the hazard ratio does change a little bit there. It goes to 0.72. So it's a weaker effect if we include absolutely everybody in the analysis. And then finally, if we do an analysis that only leaves out this 20th group here. So remember, this is the group where I'm worried that this stratum here of unexposed people with high scores have got an artificially low rate of death. So if we leave that group out, then our hazard ratio goes back to 0.6. So in fact, this difference between 0.72 and 0.66. Qualitatively, it may not be that big anyway, but in fact, I think numerically, it's entirely driven by this strange group of unexposed who have a very low risk of death compared to everybody else. So our conclusion was that there seemed to be potentially some protective effect of taking a statin if you get pneumonia. Now, obviously, you would expect that people who are taking statins have a protective effect against death anyway, because we know from trials that the statins protect you from death. This effect of 0.66 or 0.67 is a bit stronger than you would expect from trials. So we imagined that this was potentially some additional protective effect if you have pneumonia. So people have claimed there may be anti-inflammatory effects of statins that may have additional benefits. Aside from this, we did a much bigger study where we looked at about 30 different outcomes for statins, and we found no difference between exposed and unexposed for a whole range of outcomes that people have suggested may be either caused or prevented by statins. This was the only one where we saw an effect.